from grade 12 STEM 7, and today we are going to present to you our investigatory project. This project was constructed with the solution of innovating a machine with advanced technology for agriculture and better survival, which is all powered by a solar source and controlled with a smart toolbox laptop. The machine software is for the whole system, then the hardware is for the automated processing system and seed monitoring. The three hardware will function as a unit when connected to the setup for monitoring. The hardware of this innovation consists of the automatic fertigation process, temperature sensor, and the monitoring system where areas implemented. The model itself is called the Smart Grow Box. Consists of solar panel, the Arduino Uno, the battery, temperature sensor, PWC sensor, water pump and tank, plastic megabox walls, improvised wooden roof, lights controlled by the solar panel, and camera for monitoring.
The following tools and equipment used in this project was introduced below. All the specifications are stated and functions of how these components contributed to the project.
This component served as the energy provider for the Arduino Uno to work connected to the solar panel. The energy from the solar panel will be stored in the battery in order for the whole machine to work. Solar batteries are extremely safe to use. The major types of solar battery systems available includes lithium-ion, salt water, and lead-acid batteries, all of which are safe to use with a home solar system. These three battery types each have their own set of benefits and drawbacks.
These components serve as the microcontroller unit of the SGB machine. Arduino Uno will be the one who is responsible for all the sensors, including the opening of the valve pump on the water tank, controlling the water flow that is enough for the seedling needs, and the one who is responsible other functions. Arduino only has 9 to 20 volts, which guarantees its safety to use. Arduino is programmed to a specific codes that determines when to activate and when to stop the sensors. The Arduino Uno is situated inside a plastic megabox that protects it from external harm.
VWC sensor is responsible to determine when to water the soil, connected to the MCU, which is the one responsible for the opening of the valve pump on the water tank, controlling the water flow that is enough for the needs along with the nutrients needed by the seedlings. VWC are installed or tucked into the soil of the Smart Grow Box. The VWC sensor is responsible in retaining moisture in the soil to avoid drying out. This sensor will be helpful to monitor the temperature of the soil any time of the day.
The temperature sensor will be the one who is responsible to determine whether the seedlings need direct sunlight or enough sunlight. It will send a signal to the user's laptop for more accurate readings to fully support the plant as it grows. This is also connected to the MCU, which is the Arduino Uno. Temperature and humidity sensors are used to measure the humidity and the degree of the surroundings. These sensors give temperature measurement updates in a readable form to the LCD screen for more accurate readings to determine if the seedlings need enough sunlight or direct sunlight.
Serve as a provider of additional sunlight to the seedlings. Lights are very important to the development of the seedlings. LED grow lights are used to provide plants an additional light in order to make it grow healthy. The lights installed inside the main box component of the Smart Grow Box is safe from overheating and or hazardous incidences, for the lights and wirings are safely tucked away from the main box that contains the soil and the seed in progress. This LED light system will be helpful to monitor the seeds or plants' growths any time of the day, particularly in the night.
Megabox serve as the walls of the Smart Grow Box that will protect the seedlings from being exposed to too much sunlight, rain, and contagious environment pests. The SGV's structure is well made by a Megabox. The Megabox is made for the plant's foundational support, making the prototype outstand different weather calamities such as typhoons and drought. The SGV's foundation or the Megabox can stand up to more than 5 years because of the strong woodworks and containers used in this project.
Some parts of the Smart Roll Box are powered by a solar panel that is connected to a DC battery with 12 volts. Another part of SGB is the water pump, which is powered by a power outlet with 20 volts, while the Arduino Uno is powered by a 9-volt battery. The Arduino Uno serves as the motherboard or the brain of the SGB. It is connected to all the sensors that gives each sensors the signals of the plant's needs. All of the sensors except the LED lights are powered by a 9-volt battery that is connected to Arduino Uno. The moisture sensor focuses on the moisture of the soil. When the soil moisture sensor detects a soil moisture value that is programmed to it, it will send signals to the Arduino Uno. After that, the Arduino Uno will activate the water pump that will supply water through sprinklers made from PVC pipe. Moreover, when temperature humidity sensor detects a program value of temperature that is not suitable for the plant, it will also send signals to the Arduino Uno. This information of temperature will help users and farmers access the best place for their plants to grow. Furthermore, light sensors' main purpose is to detect if there is sufficient light that the plant can acquire. When the light sensors detect sort of darkness, it will send signal to Arduino Uno, which will activate the LED light to support the photosynthesis of the plant.